Hey class, this is Mrs. Tran-Bloom recording for our unit 2.1. It's called functions, okay? Now this packet, yes, this entire really super heavy duty packet contains a total of 27 pages. Um, you can print it out, it's on Canvas, and if you print it out, then you can carry it to class every day. And it will last us for about a month-ish. Okay, every packet that I upload on Canvas, it will always last us about 3 to 4 weeks. I'm sorry, no, 3 to 5 weeks, depending. That's the bell to go to 6th period. Okay, so since this is the first unit, I'm going to ask you to do this before I start the example. I'm going to ask you to take your textbook or your computer or your cell phone and define the 6 vocabulary. Okay. Make sure you write definitions that make sense to you, not just the first one you see or the shortest one. Okay. Make sure you find definitions that make sense to you. And here is an awesome chart or graph or picture, whatever you want to call this, that has some of the vocabularies here. So if, as you can see, I have input, independent, domain, range, dependent, output. Look at this and tell me how they are related, or just kind of mentally, write something down here how these things are related, just to give yourself a quick summary or review. Okay. So when I stamp your notes the next class, all of this right here must be completed for you to get a full credit stamp. All right. So before you go further, do me a favor and just hit pause, and then complete this first. And then come back and listen to the examples. All right. Hopefully, now that you have completed the vocab and check out the picture at the bottom of the first page, we're going to do a couple things here. So each relation can be written in 3 different ways. Okay. First way, this is called a mapping. A mapping is when you simply have some domains in here and some range in here and you map from one to another. The most important piece of the mapping is the arrow. Okay. The arrow is always going to go and point towards the domain or the range. Now in this case, because this is mapping, the arrow must always point towards the range. Okay, starts here, it ends here. This is your range, and then this is your domain. Okay. The first set of items or elements, we call it, is not always the domain. Okay, and the second set is not always the range. It depends on where the arrows are pointing. So if it's pointing over here, then we know that this is from here to here. Input, output, domain, range. All right, so the arrows are super important. So this is called mapping. The second notation or different way of writing is this is called a set, okay, or order pairs. So a set of order pairs. You always have to use these wavy brackets here to denote that this is the set. There's nothing else that's going to go in here. So, and these as the order pairs because it's input, comma output, domain, comma range, or dependent versus independent versus dependent. Okay, so your independent, it's always going to be your x. Your dependent is going to be your y. And the last one is graphing. As you can see right here, this is a coordinate plane, and we can use graphing to represent a relation. Now, a relation doesn't have to be a function, by the way, but a function can be a relation. Okay? Example 1. Oh, by the way, and if I'm going too fast, of course, this is a video. You can hit pause, rewind, repeat. Okay? So example 1, here we go. Determine whether each relation is a function. If yes, state the domain and range. So I have a mapping here and I have a set of order pairs. So we're going to first decide whether if this relation right here is a function or not. So based on your definition of a function, do you think this is a function or not? If you said yes, then you are correct, okay? Because there is one output for every input, or there's only one y for one x, or there's only one range for one domain, okay? And it's saying, hey, state the domain and range. So we're going to write D over here. You will need to use the bracket. The domain, it's all going to be, notice the arrows. The arrows over here, so we know this is going to be your domain. No high school diploma. No high school dip. I'm just going to abbreviate some of these. High school dip. So high school dip. Some college. Some college. And college grad. College grad. Okay. Close that up with a bracket. Then we're going to state the range. Okay. The range is going to be all the percentage here, the percentage of unemployment rate, and then your range is the level of education. So the range is going to be all the unemployment rates. We're going to, let's see if it can go from, I guess it's already from highest to lowest. It's already in some sort of order, so we're going to keep it the way it is. Okay. So we got 7.7%, 5.9%, 5.4%, and 3.4%. So, and the range with a bracket. Okay. Now, I'm recording this from a PC, and I don't know how to edit a video from a PC. So if you happen to know a method of editing a video, can you please, please, please come and talk to me? So if you can help me. All right. All right. Let's move on to example B. Example B is written as a set of order pairs. So we got pair 2, 3, 4, 1, 3, -2, and 2, -1. So the first part of the question is, can you tell me if this is a function or not? If you said yes, then you are incorrect. Okay? This is not a function. This is not a function. For a reason of, I have two outputs. Okay? I have two outputs for one input. So if you look at my 2, even though 2 is in two different places, but it's just still the same 2. Okay? So let me map it for you. So it's easier to see a function in mapping way. So let's talk about the inputs and outputs, x and y. Okay? We got 2, we got 4, we got 3, we got 2 again, but I already have 2 over here, so I'm not going to write it again. We got 3, we got 1, we got -2, and we got -1. None of those are repeated, so I do have to write them all out. So first 2 is mapped to 3, so arrow go that way. 4 is mapped to 1, so arrow go that way. 3 is mapped to -2. And then the last one, 2 is mapped to -1. Okay, so check this out. What's happening with this one input? It has how many outputs? It has 2 outputs. Therefore, this is not a function. Okie dokie? Okay, so your next task is going to be completing this check for understanding. Check for you. Hoo-hoo-hoo. Okay, so this is actually, it stands for check for understanding. And check for understanding is usually you are going to complete this on your own. Try it out on your own. Okay, so again, when I stamp your video notes the next day, I do expect for you to complete both of these. So on your own. Happy face. All right. So before we move further, I should try to tell you a little joke. Okay, so as you know, I have 4-year-old triplets, okay, identical girls, and they love jokes. Oh my gosh, like my family is totally corny. We love silly, funny jokes. We laugh at ourselves. We make fun of ourselves. So you're gonna get to hear a lot of silly toddler jokes. So my first toddler joke of the video is, why did the sun go to school? Why did the sun go to school? To get brighter. Ha ha ha. Welcome back to school. Okay. where hopefully you're done with that. And if you're not done with this, please pause it before we go on, okay? Example 2. Determine whether an equation defines y as a function of x, okay? So that means if y is a function of x, that means x is your input and y is your output. And remember, the definition of a function, you define that already, okay? For every input that you have, you can only have one output, okay? So let's talk about this right here. Y equals negative 1/2 x minus 3. What curve is this? If I graph it out, what would it make? Is it going to make a line? Is it going to make a parabola? Is it going to make a circle? What curve do you think this is? Okay. This is going to produce a line with a y-intercept of negative 3 and a slope of negative 1/2. Okay. Now, let's check to see if I'm going to get multiple outputs for one input. So when the input, which is x, let's just say 0, I would only have one output, which is y equals to negative 3. When the input, let's pick another one, like 5. Okay, well, that's a hard one. How about 6? Negative half times 6 is going to be half of negative 6 is going to be 3, right? And then multiply that, I'm sorry, half of 6 is 3. Then multiply to negative 1, so negative 3. Negative 3 minus 3 is a bigger negative, so that's be negative 6. And again, that's only one output. And another way of checking is too, hey, if you think about it, if it's a line, okay, we're just going to sketch this out really quickly. Y-intercept of negative 3. The slope is going to be negative 1/2, so I can go up and then left. Because I'm sort of, I don't have as much space on the bottom, so it's going to go this way. Okay. All right, so check this out. If it's a line, then would you agree that I would only cross, my vertical line test would only cross this line at most one time? Doesn't matter where I place it, it will only cross over the line one time. So that's another way to, if you know how to graph it out to see if the vertical line test pass, okay? So yes, this is, yes, because there is only one output for one input. And I can't just, all right, sorry. Okay. Please don't write it passes the vertical line test if you don't have this graph. Okay. If you graph it out, then yes, you may state the reason as it passes the vertical line test. But if all you have is an equation and you say, oh, it passes the vertical line test, what are you passing? I can't just have a vertical line test, which is, by the way, my pen, on the equation itself. Okay. So use it passes the vertical line test as a reason if and only if you have a graph. All right, next, we have this one right here. X equals 2y squared plus 1. Okay, so remember, to have or to be a function, you may only have one output for each input. So let's say my input, remember, this is my input. So my input, let's just say, how about if I want to be like 1? Is that all right? Let's test it out. So input's 1. How many outputs am I going to get? So let's solve for y. 1 equals 2y squared plus 1. And by the way, you can use whatever input you wish. Just test out a few to see if it's consistent, okay? Minus 1, minus 1. So this is 0 equals 2y squared. Divide both sides by 2. 0 divided by 2 is going to be 0 equals y squared. Okay. Square root, both sides. Square root of 0 is still going to be 0. Huh, check it out. Input is 1, one output. Must be a function, right? No, you can't really stop right there. That's only the first input that you tested. You might want to test a couple more. So I'm going to pick another one. Let's just say 4. Okay. So we're going to do 4 equals, I'm just randomly picking inputs here because this is just x, which is representing any domain or any x or any input you wish. And this is y squared, that's representing any output. So since we don't know what the input and outputs are, we're just picking random x values, okay? So 4 equals 2y squared plus 1, okay? Subtract 1 to both sides. So 3 equals 2y squared. Divide both sides by 2. So 3 over 2 equals y squared. I'm going to take the square root to both sides. Okay. Remember, when you're taking the square roots, you're going to end up with how many solutions? You're going to end with 2. It's called plus or minus. 3 over 2. Okay. So what is a plus or minus? What does it represent? It represents 2 different solutions, right? So 1 input, but you got 2 outputs. Therefore, this is not a function due to the fact, and you please spell this out, I'm kind of running out of space, due to the fact that you have 1 input for 2 outputs, okay? So notice the first test that I did, I got 1 input and 1 output, so most of you are going to write, oh yay, it is a function. But remember, you always want to test out a few of the numbers. You can't just test one and then decide right away if that's the correct answer. Okay? All right, make sure if I'm going too fast, hit pause before you go on. Okay. So now that you are done copying, we have another check for understanding. So check for understanding, determine whether an equation defines y as a function of x. So this is exactly what we just finished on example 2. So of course, you are going to do this on your own, okay? And if you don't understand these, please come and see me at tutorial. So 2 things, you can ask me to see if your answers are right. And 2, if your answers aren't right, then at least you have the opportunity to ask questions and learn it the right way. Because of course it's going to be on every test you're going to see. Okay. Hit pause really quick, finish up your check for understanding. Because from my experience, if you skip it, you are going to forget about it later. So might as well just hit pause and do it right now, okay? Okay, this is example 3. And I'm thinking this is going to be our last one, okay? Here we go. Let me see if I can make it any more clear, because to me it's not very clear. But hopefully it shows up more clear than what I'm seeing. Clearer. Example 3. For the function f, defined by f of x. So this is your input, and f of x is your output. F of x is the same as saying, hey, y equals. So f of x equals negative 3x squared plus 2. Evaluate, okay? And then it looks like a sad face, but it's actually 2 separate things here. Colon and then parentheses. You will need an extra sheet of paper or use the back. So let me see if my back is blank or what. Yep, the back of my handout, packet is blank, so I'm going to be using the back of my handout in just a sec, okay? So for this one, be neat. Be super, super neat, because it looks like there's a lot of things. You got A, B, C, D, E, F, G, okay? So here we go. A. I would like for you to find f of 3. Okay? So what does it really want you to do? Our original function is this. Okay? But I don't want my input to be x anymore. Now, I actually want it to be a value of 3. So every time you see an x, you're gonna change it. Okay? Change it to what? There's an x there and there's an x there. Notice how all my numbers are staying constant, staying the same place. So every time you see an x in there, you're going to change it to this input, which is 3. Okay. Then let's calculate to find what our answer is. Here we go. 3 squared is 9. 9 times negative 3 is negative 27. 3 times 2 is 6. So this is going to be negative 27 plus 6 is negative 21. So f of 3 equals negative 21. Okay. Or 3 comma 21. It's also acceptable because I know the input is 3, the output is 21. Oops, I'm sorry, negative 21. Okay. All right, B. Let's try to be neat. B, here we go. I'm going to divide this into 2, like that, okay? So split it in halves. 2 halves, I meant. here we go. B, it's asking you to find f of x plus f of 3. Okay. Do we know what f of x is? Do we know what f of x is? Okay. Let me zoom in, all right? Because I only need to focus on the function, okay, and then b. So right now, my question to you is, do we know what f of x is? F of x equals. So now we're going to take out f of x and put in this. Let me just write this question first, okay? I'm asking you to find f of x plus f of 3. F of x is or equals to this. Because I want to evaluate or find the answer, I'm not going to leave f of x as f of x. I'm going to write negative 3x squared plus 2x. Okay. Do we know what f is when the input is 3? When the input is 3, f is negative 21. So of course, and I'm just going to add those together. So add negative 21. Okay? So add negative 21. Now if you look at this, there's nothing I can do. I can't really combine them. There's not much I can do. This is a square term, this is an x, this is a constant. So guess what? I am done. Right? Not much math needed to be done on that one, except understanding the notations. Okay, next, I'm asking to find 3 times f of x. Okay, so that's your C. 3 times f of x. Okay. Similarly, just understanding notations. What does that mean? Do I know what f of x is? Can you tell me what f of x is? Okay. So, if you remember, f of x is this. So, f of x is negative 3x squared plus 2x. And what I want to do is I'm going to multiply this whole shebang by 3. And so 3 times f of x is, looks like that's going to be negative 9x squared plus 6x. And that is going to be my final answer. Alright, next I'm asking you to find f of negative x. Okay, so instead of just a regular input of x, what is your input now? I want my input, oops, you can't see that. Here you go, let's zoom out. Okay, I want to change all of my regular inputs to negative x. So here we go. I'm going to write all the numbers first. Okay. There you go. These blank spaces are where the input, the x used to be. So now I have a new input. So negative x goes here, negative x goes here. So this will leave me with f of negative x equals negative x squared is going to become positive. Okay? So positive x squared times negative 3 is going to be negative 3x squared. So that and that did not change. Let's see if this is going to change. 2 times negative x is going to be a negative 2x. So when I substitute it with negative x, looks like the only thing is this back piece, because everything's square, negative or positive, it will always be positive. Okay. Okay, next. Earlier, we computed 3 times f of x. Okay. This particular problem, I'm asking you to compute negative 1 times f of x. So that's your E. Negative 1 times f of x. When you see a negative with no number, that means it's negative 1, or negative 1 times f of x. Okay. And again, we know what f of x is. I'm going to move up, so I'm going to be hiding f of x. But by now, we know negative 1 in parentheses if you wish. Okay. F of x is negative 3x squared plus 2x. Let's distribute. So that's going to give me negative times a negative is a positive 3x squared. Negative 1 times positive 2x is minus 2x. And notice how this is my answer. And because I multiply by negative 1, notice how the signs right here have changed. Okay. Next, okay, on f, I'm asking you to find f of 3x. Okay, so every time you see an x, you are going to substitute it with 3x. So here we go. F of x. Oh, nope, I don't want f of x. F of 3x. My bad. Okay, equals. Now I'm going to write these two terms right here and leave blank spaces for the 2x there. So if I have a negative 3 and I see an x and then square, then I have a positive 2 and then I see another x. Okay. These two blank spaces, this is where I'm going to put in 3x. 3x. Okay. Then let's try to simplify this. 3x squared, that's going to be 9x squared. Okay, so negative 3 times 9x squared. 2 times 3 is going to be positive 6x. Negative 3 times 9 is going to be a negative 27x squared, and bring down my 6x. So f of 3x, okay, will result in a negative 27x squared plus 6x. Now, it's about 26 minutes-ish right now. My videos would never go over 30 minutes, so I normally stop around 25, okay, because I figure if I go any further than 25, it will usually a problem. It's longer than 5 minutes, so unless it's unless there's something that's super quick, then I will continue. But right now, we have 2 more letters left to be done, and we will do these in class, okay, the next time I see you. So go back to your notes, look over all the stuff that you're supposed to do on your own and complete them before you forget. And then if there's something that you don't remember or don't know or don't understand, come see me. Have a wonderful day.